Diode reverse polarity protection. When would you want reverse polarity protection? A lot of electronic equipment works fine if a positive voltage is applied across it. The current flows positive to negative and the equipment works. However, many electronic devices get damaged if a negative voltage is applied across it. The current flows in the negative direction, and equipment such as microcontrollers, MOSFETs, and polarized capacitors can be easily damaged. Reverse polarity protection allows positive voltages and blocks the negative voltages. A simple solution to this problem is diode reverse polarity protection. This is common in the automotive industry because it is reliable and easy to design. It simply consists of a diode in series with your load. Your load voltage will be equal to the source voltage minus the diode voltage. For example, if your source voltage is 5 volts and the silicon diode's forward voltage is roughly 0.7 volts, the load voltage would be 4.3 volts. With a negative 5 volt source voltage, the silicon diode blocks the current, making its reverse voltage match the source voltage, and so there is effectively no voltage across the load, preventing damage to our electronics. I want to outline some design considerations to take into account for this circuit. Your biggest choice is whether to use a silicon or Schottky diode. Silicon diodes have a higher voltage drop across them of about 0.7 volts versus the lower voltage drop of the Schottky, which is 0.3 volts. This means silicon diodes consume just over 2 times as much power as the Schottky equivalent. The silicon diode has the advantage of excellent blocking characteristics, which is in the microamps, versus the Schottky diode, which will leak milliamps. Milliamps may be too much for some devices, so you need to be careful when selecting your diode. Using diodes for reverse polarity protection has the advantage that it is a simple and reliable solution with only one component. A key disadvantage is the voltage drop. This takes voltage from the load, and this may be unacceptable for some low voltage designs. The other disadvantage is the power losses and heating. In high current designs, the power losses may cause the diode to get too hot. Next up, we'll look at how diodes can be used to handle multiple power sources.